This is the final video on sequences, bounded and monotonic. All right, let's get started. A monotonic sequence is if its two terms are non-decreasing or non-increasing. Notice the less than or equal to. That means it could be the same values. Okay, so these values are basically increasing except when it's not. But it doesn't switch to. But it doesn't switch to decreasing, right? So it's continually going up, but it does not go down at all. So this one is continuing to go down, but doesn't go back up, okay? All right, but it can level off, I guess I should say. All right, let's look at this. Determine whether each sequence having the given nth term is monotonic. Is this monotonic? Well, recall that a sub n, right? You've seen this before, alternates between 2 and 4. And I want you to notice that the author is not even consistent with his notation. Before he used those set notation. So I guess it's not important enough. Anyway, all right. So because it alternates between 2 and 4, it's not monotonic. All right, and look at this one. Determine whether each sequence having given this nth term is monotonic. We're going to compare b sub n to b sub n plus 1. This is the way the textbook does it. So b sub n looks like, of course, what it is, and then b sub n plus 1, you put n plus 1 in the place of n, and this is what you get. And let's look at sign. And we want to know if it's less than, I guess we could also put the greater than sign. All right, but we want to know if that comes out. Okay, and, well, nothing to do with the left. On the right, there comes 2n plus 2 over 2 plus n. And what we're going to do next is multiply. All right, so n is a positive integer, so we can multiply both sides by this common denominator, right? So if we multiply the left side by 2 plus n, multiply the right side by 1 plus n. Well, technically, we're multiplying both sides by both denominators, except on the left-hand side, the 1 plus n would cancel, and on the right-hand side, the 2 plus n would cancel. All right. So you can think of this cross multiplying if you want, that's okay. So it's 2n times 2 plus n, and 2n plus 1, and 2n plus 2 times 1 plus n. And we still don't know whether one's less than the other or not, okay? So go ahead and work it out. That's what you get. And notice we got 2n squared here, 2n squared here, 4 and 4n, okay? So basically those don't matter because they're equivalent. And it leaves 0 on the left and 2 on the right. So yes, 0 is less than 2. So that means b sub n is less than b sub n plus 1. Okay, so it is monotonic. Alright, now what is this? Well, this is the functional version. And sometimes, and quite frankly, I think usually, it's easier to look at the derivative to determine whether it's monotonic or not. So here, I've taken the derivative, right, using quotient rule, and I get this expression. Now look at this. This is always positive. That means it is always increasing, right? So that last screen you saw, where I was comparing b sub n to b sub n plus 1, right, I think that was a little more complicated, and so you don't have to do it that way. Taking the derivative is easier, and you're probably more used to it. All right, so it's always increasing, so it's monotonic. Let's look at this one. Ooh. Well, we're going to look at the graph of this one. There's no easy way for this. All right, so look at the graph. So looking at the graph, it's monotonic after 2. Okay, it's monotonic after 2, but if you begin at 1, it's not monotonic. So sometimes though, we're going to get picky about it, and we could just say, well, let's just get rid of the first term. Let's say n starts at 2, then it becomes monotonic. All right. This is the definition of a bounded sequence. A bounded sequence. Now, this is the Matthews version. I'm going to kind of paraphrase it here. You can have an upper bound, so that means it doesn't go above a certain value. Or you can have a lower bound, and it doesn't go below a certain value, right? So number 1 is bounded above, so it doesn't go above a certain value. And number 2 is bounded below. Now, number 3 says if you bound it above and below, right? So when we use the word just bounded, it's bounded above and below. If we only want a bounded above, we say above. Bounded below, we say below. But if we want to say both at the same time, we don't use any word. We just say it's bounded. All right. If a sequence A sub n is bounded and monotonic, then it converges. So this is saying bounded above and below it. Okay, so this theorem requires that a sequence be bounded above and below and be monotonic, then it converges. All right, let's look at the first example here. Okay, 1 over n is bounded above by 1, right? It doesn't get any higher than 1. And if you take the limit as n goes to infinity, it's bounded below by 0. And if you take the derivative of that, you get negative 1 over x squared. So it's decreasing. It's always decreasing. All right. And so A of n is monotonic. So by theorem 9.5, it converges. Now, this one was relatively easy. You probably don't need theorem 9.5 to decide that this converges. So this was an example. Remember, frequently in math, we start with a very simple example where you can confirm it with your common sense. Well, I guess there's not much common sense about any of this. But if you already knew that 1 over n is going to 0, you probably didn't need this theorem to say that. What it is, this is just an example of confirming what you already know. All right, let's look at this one. Okay, so this one, if you take the limit as n goes to infinity, well, it's infinity, so it's not bounded above, so it diverges. Right? It's a divergent sequence. It's not bounded above. All right, this is bounded above by 1 and negative, bounded above by 1, bounded below by negative 1. Right, so it's going to be negative 1, or negative 1, then positive 1, negative 1, positive 1, negative 1, positive 1. It's not monotonic, so it's divergent. Right, it's bounded, but it's not monotonic because it goes back and forth. So it's a divergent sequence. And that's the end of part 3. There is no part 4. Alright, let's kind of summarize what you should have learned from all 3 videos. So in part 1, there was the basics of sequences, right? The notation and how to just evaluate values, right? It's same as a regular function. We took the limit of sequences. That was part 2. That's one of the more important videos, right? To be able to take the limit of a sequence. And the bounds of a sequence, we looked at it here, okay? Basically, it's very similar to taking the limit of a sequence. If you take the limit of a sequence, you probably found the bounds. Whether a sequence is monotonic or not. That was, it says part 4, but it was part 3. There is no part 4. All right. I need to work on my typing skills. Anyway, so whether a sequence is monotonic or not was in this video, not part 4. There is no part 4. All right. That idea for sequences, it's easier if you take the derivative. Right, if it's always positive or always negative, or positive after a certain value. Okay. All right. So that's it. That's sequences. Now the bad news is, I know there was a lot of material, but this is only the background information we're going to go into when we get into series, and that's the biggest part of this chapter is a series. So sequence is background information, or it's like prerequisite skills for what we'll be doing with series. All right. So in class, you'll be given only 1 day to work on some problems. So make sure you use your time wisely. That's it. Alright, and all that we did was determine whether a sequence converges or diverges. And that's going to be important. Now, what it converges to or diverges to, well, I guess it doesn't diverge to anything. What it converges to is not going to be important. The most important part is to know that whether it converges or not. Okay, that's going to be the important part. Alright.